All righty. Oh, too far, too far. All right, page 612. Oops, I'm going to keep this pen. I don't think actually. We're going to take a look at how we can show that two triangles are similar. What is enough? What is enough information to show that two triangles are similar? So again, we're going to continue focusing on triangles here, okay, and determine what is necessary to show that two triangles are similar. But again, we're starting on page 612. All right. So first things first, we have some triangle similarity theorems, right? Just like we had triangle congruence theorems, side, 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 angle, side, angle, angle, side, not side, side, angle, not angle, side, side, right? Not those. Hypotenuse leg was one that worked too. We're also going to have similarity theorems for triangles. So for example, angle is a triangle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Okay? Because really, if two angles of a triangle are congruent to two angles of another triangle, how many angles are really congruent? All of them, right? Because if you know that two angles are congruent to two other angles, well, that third angle you can get by subtracting from 180, and guaranteed then the other one will also be the same as well, because you get the other two angles, subtract those from 180, it'll be the same measure there. Okay? So angle similarity is really angle, but we just say angle. All right? So we're not going to necessarily like run through the proof here or anything like that, but that's just something that we've got now. Okay? So whenever we see two angles in one triangle congruent to two angles in another triangle, guaranteed that they are in fact similar triangles. Okay? So that's all we need there. Okay, to worry about for that piece. Okay. So you can turn the page, or look at page 613 now. So let's take a look here at number 3 though before we move on. Okay. So number 3 here says in triangle JKL, the measure of angle J we're told is 40 degrees, and the measure of angle K is 55 degrees. In another triangle MNP, the measure of angle M is 40 degrees, and the measure of angle P is 85 degrees. A student concludes that the triangles are not similar, right? If we have a 40 and 55 degree angle here, we have a 40 and 85 degree angle here, we have one pair of congruent angles, but the other pair are not congruent, and so therefore we do not have angle similarity. Do you agree or disagree about what that student is saying there? Is that student right, that they are not similar triangles? What do we think here? So, Avery, let's give you a go.
Yeah, because even though angle K and angle P don't correlate, you can solve for the third angle, but you can tell that, oh wait, no, never mind. I thought that was 45 degrees.
Okay, so J and M, they are congruent, right? So like check to J, check to M, they're congruent, right? 55 degrees, you said, is for K, and you said that does not match, it doesn't correspond to P. What does K correspond to? To N, right. So we have P, 85 degrees, but that corresponds to angle L. So we should maybe try and figure out what angle L is here, right? And like you said, we could subtract from 180, right? So 180 minus 40 minus 55. Well, what's that going to be? It's going to be 85 degrees. Okay, so the measure of angle L is 85 degrees. The measure of angle P is 85 degrees. So we can say triangle JKL is similar to triangle MNP by angle. Okay, similarity. I'll write that out. Angle similarity theorem. Okay. So in fact, the student is wrong. So make sure that you're checking corresponding angles there for the angle similarity. So let's take a look here at how we can then apply and use angle-angle similarity. Okay. So, for example, architects and contractors use the properties of similar figures to find any unknown dimensions, like the proper height of a triangular roof. They can use a bevel angle tool to check that the angles of construction are congruent to the angles in their plans. All right. So we talk about that context, and then we go to this weird abstract thing. So that's kind of like a weird little segue that they give us there. But anyway, so the question, we're directed to find the indicated length if possible. So here, for example, BE. All right, we want to find this length here, BE. Well, first we want to determine, are these two triangles similar? Now, if you look here, do we have any congruent angles that are marked? None of the angles are marked congruent, but can we say that any of these angles here are congruent? All right, so Madison, you said yes, so what can we mark congruent here? So be careful, we want to mark angles. Okay, all right, angles here. Preston?
ABC.
We have these angles are congruent. Why? Vertical angles are congruent. Okay, so we have one pair of angles that are congruent. Can we come up with anything else that must be congruent here based on the way this diagram is drawn with the given information, I'll say? Madison?
The two parallel lines.
Okay, so the two parallel lines, those can create congruent angles. So what angles will be congruent based off of that?
ACB.
So this angle right here and DEB, yep. And if you wanted to there, you could have just said C and E if you wanted to, because that's all. Jenny, you have another one?
Well, angle A.
Yeah, an angle A and D would also be congruent by the same argument. They're alternate interior angles. So very good. I'm glad you gave the justification of two masses. That's good. Okay. So wow, are these triangles similar then? Yes, similar by angle. Okay, we didn't really write a proof, but we basically did all the work of the proof. Okay. And as it turns out, I know we just finished talking about benchmark number 1, but of course we do have a benchmark number 2, and the benchmark number 2 tends to have a proof for triangle similarity here. So we basically just kind of did one right there. All right, so since they're similar, we can now figure out what BE is going to be. So Jenny, I know you weren't here yesterday. Do you want to try and give it a shot here, though? How we can figure out what the ratio would be for segment BE there? What over what equals what over what? So that's 36. What does that correspond to in this triangle? So it gets a little tricky, right? Because the triangles are turned and flipped and rotated. So maybe it'll be helpful if we actually state the congruence, state the similarity statement here. So triangle ABC is similar to. Now notice how I went here. I went from A, which had the 3 markings, to B, which has the 1 marking, to C, which has the 2 markings. So where should I start here? D, right? D to then B to E. Right? A, B, C. So 3 to 1 to 2. So 3D to 1, B to 2E. Do you see that okay? Yeah? So then AB, according to our similarity statement here, what does AB correspond to over here? DB. So 36 over 54. Okay? Now some of you guys, you'll be able to look at this and just know, oh yeah, 36 and 54, they correspond. You can also tell because 36 is between the 3 and the 1 arc there. So then between the 3 and the 1 is 54. That's another way to look at it. But anyway, 36 over 54 equals, what's the other ratio going to be there, Jenny? (54 over x). Exactly right. So we cross multiply here. Okay. We get 2,000, we get 36x equals 2,916. Divide both sides by 36, and you get 81. Okay? So x is 81. Or in other words, BE is 81 there. Questions on any of that? No questions on any of that? Real good? Okay, so let's move on to the next one here. So then letter B, different scenario now. We have a segment RT that we want to find. RT. So we want to find this full length right here. Okay, and figure out what is RT. Okay, now first we have to determine, are the triangles similar? If they're not similar, we're done. We don't even have to keep going. Okay? I see one pair of congruent angles right here between the two triangles. Do we have another pair of congruent angles here? Emma? R, that's right. It's shared by both triangles, right? The big triangle is R, and the little triangle also has R. We could say those two angles are congruent because of the what? Angle R is congruent to angle R because of the reflexive property of congruence. And so the triangles are similar here. So we will say triangle, I'll name the smaller triangle here first. We'll say triangle RSV is similar to triangle, and then how must I name the next triangle? RSV is similar to what? RTU. Okay, oops, I'm off the screen. There we go, RTU. All right. So, Dylan, can you help us set up the ratio here that you could use to solve for RT? We'll call maybe RTX there instead. So what's a ratio that we can set up here? What over what equals what over what?
RS over TS.
Okay, so RS, the 10, over, not ST though, because that's only part of a side, right? So it'd be RS over what? Remember, RS
Over RT.
RT, which is going to be what we're solving for. So 10 over x equals, and then what's another ratio we could use here? So you,
SB over D.
yeah, very good. 8 over 12. Good. Okay. So 12 times 10, 120. 8 times x, 8x. Divide both sides by 8. And we get 30, 15, I believe there. Yes, 15. Okay, so RT is 15. Okay. Very good. And good job catching yourself there, Dylan, that you didn't do the ST stuff. Okay, ST is not a full side of a triangle. Later, we will see there is a relationship. RS over ST is in the same proportion as RV over VU. So RS over ST is the same proportion as RV over VU. That's true, but we haven't gotten to that yet. Okay, so we really only want to match up corresponding parts. So 10 is the full side of the RS of the triangle. So RT is the full side. 8 over 12, both are full sides. All right, turn the page. Okay. All right, so I'm going to take a look here at number 5 before I have you guys try one on your own. Okay, so number 5, when asked to solve for y. So you can see here in our problem, we've got 8 is the length of CE. Y is length from A to C. AB is 14. CD is 10. When asked to solve for y, a student sets up the proportion as shown. Explain why that proportion is wrong. Why is it wrong? What is wrong with that proportion? And then how should we set up the proportion correctly here? Okay, Emma, go for it.
Because y isn't like the full length, so it needs to be y equals 8.
Yes, y is not a full length of a side. Or another way to say it, y does not correspond to 8. All right, so can you fix it for us, Emma? What should the ratio actually be?
Y plus 8.
y plus 8 over, okay, yeah, so y plus 8, the full side of the big triangle, over 8, the full side of the smaller triangle, equals full side 14 of the big triangle over full side 10. Very good. Thank you, Emma. Exactly right. Okay. Questions on any of that? So we hit it one more time there for you to make sure. All right. Why don't you guys go ahead and try 6 and 7 then, right there. Give 6 and 7 a try. A builder was given a design plan for a triangular roof as shown. Explain how he knows that triangle AED is similar to triangle ACD. Then find the length of AB. So find the length of AB. And then for 7, find PQ if possible. For 7, find PQ if possible. Okay. Find PQ if possible. So go ahead and get those going. Okay. So number 6 looks good. So be careful what you're matching up corresponding parts here. It might be helpful for you to write the triangle similarity first, like triangle blank 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 is similar to triangle blank blank blank, and then make sure that you match up corresponding pieces because you didn't quite match the corresponding parts. Yes. Well, let's see. So what are we trying to find? AB, right? Which is this full side right here. Right? Call that X, because you don't know it yet, right? Okay. So 9 over 15, perfect. 9 is the full side here. We'll be matching full side here. 15. That's good. Okay. So 9 is from the smaller triangle over 15 from the bigger triangle, right? So then what's another side of the small triangle that we know? 6. So we want to set that equal to then, equals 6 then over, and then what's the matching full side right here? We don't know it, right? So, well, we can do that, or we can just say X in this case, right? Because we want to find the full side, so we're split over X. See how we set that up? Okay. In the past, we were given like this, and so we had to add these pieces together. But since we're just trying to find this full side, we can just call that full side X. Yeah. Okay, so 9 or 15 equals 6 over X, and then you want to solve it there, okay? Figure out whether it's similar or not yet. So, we got that one. We also have parallel lines here. Okay? Cross by transversal. If I extend that out. One of these triangles be similar, sorry, congruent. It's your choice, really. As long as you're consistent with it, of course, right? So be consistent, that's all. So good. Let's check this out. So what I might recommend you do, write the similarity statement for these two triangles. Like triangle TSQ is similar to triangle blah, blah, blah. And then use that to maybe help us out your ratios and stuff. Okay, try that if you want to. Yeah. So you can, so the way you set this up, you can kind of set it up this way. I would recommend against it, but you can work. So you match this side of the smaller triangle with this side of the smaller triangle, right? 6/9. So in a similar sense, you need to match those corresponding sides in the bigger triangle, the matching side, right? Which you did at first. So you need 6/9 equals 6 plus dB over, what should be over 15 there, right? So put it over 15, then cross point. Remember, you're also trying to find A, B, okay, but so fix that, and you can cross multiply and solve. You're not wrong there after that. You fix that. So good. What I recommend you do is write the triangle similarity statement. Write this triangle similar to this one, make sure you match the corresponding pieces, and then that'll help you set up your ratios, okay? So good for that one. Stuck on that one, try writing the triangle similarity statement. So 15/9 equals x plus 6/6. That should work, but of course, you're trying to find. No, what you did there is not wrong, but what further step you have to do? You found the length of dB is 6, so then it should be that, but then. Say 1/9 equals x plus 6/6. Okay, so 9. So 6 times 15 gives you 90, but then when you multiply 9, it should be 9 times x, 9 times 6. Okay. There you go. So yeah, so you want to fix that. All right, y'all okay here? This is good. Yeah. Yeah, that's right. This one's not quite right. Let me see. Oh, I see why. You said this. Remember, you're trying to find AB. So if that's 4, what's that full length going to be? So it's 10, which would be fine. So, yeah. Okay, but otherwise, good job. Well done. Tired? Okay, well, this helps if we start on the right page here. So we're trying to find AB. Okay, so you can set up a ratio here. So AB is this full length right there. That's what we're trying to find. Okay, so you can set up a ratio with corresponding pieces to get it right. Okay, so you can do it this way. So yeah, set up. Oh, I see what you mean. You did 6/9. Okay, so this side over this side. Then you should do x over 15. You should have these flipped around. Okay, so make it x over 15 and then cross multiply and solve. Okay, and you should be okay. Good, that one's good. This one, I recommend write the triangle similarity statement first. Like triangle TSQ is similar to triangle blah, blah, blah over here. Then use that to help you set up your ratios, okay? No, it's okay, this is fine. It doesn't bother me, I'm just like, that's good. This one's not quite, that's okay. But, yeah, but that's good, that's good. So we'll talk about this. Okay, very good, I'll do that too. Yes. Yes! Much better. Good job. Yeah, that's similar to that. What things are going to be in similarity, what things are the same? so be careful how you say this. I think so TSQ, it should be then PSR. So that might have thrown you off with some of your setup. 67. Let's see. Okay, that one's good. That one's not quite right. It equals. So what is the length of AB you're saying? 10. Yeah, that's right. This one. Okay. Ooh, these are a little tricky, aren't they? Aren't they? So, let's take a look at these. Okay, we'll look at this one first here. So first we have to determine, are the triangles similar? Yes, they are similar. How do we know? By angle in this case, right? We have parallel sides, crossed by a transversal, so we have corresponding angles, they're congruent. We are interested in side AB here. Okay, we're interested in side AB, the full length. Okay, so how do we set this up? Again, I see some of you not matching up corresponding sides, and that's okay sometimes. So some people started off with like 6/9, and that's not wrong. But again, it's I don't know. It's gonna be you make things just a little bit trickier for yourself when you do that. I would always recommend you match up corresponding pieces. So what matches here? 9 should go with the 15. 9 is this full side, 15 is this full side. So 9 over 15 equals 6 is the full side of the smaller triangle over AB, which is x. Okay? I saw some of you like calling it, 6 plus x here. That's fine. You can do it that way, but just understand we're trying to find the full length AB. So I call it AB my x, the unknown there. So 9 over 15 equals 6 over x. Cross multiply and solve, we get x is 10. So we get x is 10. Right. Remember, you can use your similarity statement to help you identify corresponding pieces. ED and CB. ED, CB. Right? AD, AD, AB. Right? So that's how you can use it to help you. All right. Let's now take a look at number 7. Okay, so first of all, are the triangles similar? Yeah. Angle, 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 angle. Right? That's going to be 90 degrees. It's helpful here, my recommendation was to write out the triangle similarity. Triangle TSQ is similar to triangle PSR here. Okay? 9 in this triangle, corresponds to what in this triangle? SR12, right? QS, SR. So 9 over 12. 9 over 12. Equals 15, the TS. That's got to match to PS. What is PS? PS is x, the unknown PQ, x plus 9. 9 over 12 equals 15 over x plus 9. Cross multiply and solve, we get x is 11. PQ is 11. 11 there. Okay, 11. Questions on any of that? Okay. This is a little bit trickier than congruence, right? It's a little bit trickier. Things aren't just equal. We got to be able to set up these ratios. So it makes it a little bit trickier. All right. We'll get some more practice with that, though, in a second here. Okay, so of course there are other triangle similarities that we can use too. Besides angle, angle, there's also side, 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 and side, angle, side. If 3 sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. Or side, angle, side. If 2 sides of one triangle are proportional to the corresponding sides of another triangle, and their included angles are congruent, then the triangles are similar. Okay? Then their included, the included angles are similar there. So that's the idea. Oop, I think I've lost where I was. Let's see. Oh, here we go. Okay? So we've got angle, angle. We've got side, angle, side. We've got side, side, side for similarity. But if you remember in congruence, we had side, side, side. We had side, angle, side. We didn't have angle, angle. We also had these two as well. Angle, side, angle, 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 side. And of course we had like hypotenuse, leg too. Okay? So we have side, angle, side. We have side, side, side. But what happened to angle, side, angle, and angle, angle, side in congruence here? Why don't they show up in our similarity? Avery?
You only need the two angles, you don't need the
Yes, angle side angle is angle angle, right? Two angles. Angle side is angle. Two angles again. Okay, and so really we do have our same congruence theorems. We have like their corresponding similarity theorems. All right, it's just angle side angle and angle side become angle. And then hypotenuse leg. Well, I'm not sure about that. I have to look. What happens with that one? Okay, I feel like it should still work too. All right, so anyway, same principles still apply here. So if you go to page 615, you'll see, okay, for example, here we have two triangles, right? We want to determine whether they are similar. Okay, we want to determine whether they are similar here. And so if you look, we want to check that the ratios are equal. Excuse me. So this is potentially a side, angle, side, right? And then side, angle, side here. So the 4 from triangle MN, what does that correspond to? The 6. So we'll say 4 over 6. And I want that to be in the same ratio as, what's another side of triangle MNP that we know? It's going to be, 8. Jenny, is that what you're going to say? Sorry, 8. So 8 is the small triangle side over, and then what's the corresponding side in the bigger triangle? 12. MQ, which is 12. 8 plus the 4 there, so over 12. Is 4 over 6 the same as 8 over 12? Yeah, they're both 2/3 when you simplify them, right? Simplify this by dividing top and bottom by 2. Simplify this by dividing the top and bottom by 4. They both end up being 2/3. So similar by SAS, side, angle, side, similarity theorem. Okay? All right. So again, it's a little bit tricky, right? Because we've got like the triangles put together there, so you want to be careful that you match corresponding pieces. The 4 match to the 6. The 8 matches to the 12. All right. Letter B. What potential similarity theorem are we going to use here? Side. Okay. What's the 4 going to match to in this bigger triangle? Okay. What's the 8 going to match to? The 12. And what's the 10 got to match to? The 15. Okay. If you're concerned that you're not going to be able to do that, match the smallest side here to the smallest side here. Match the biggest side here to the biggest side here. And match then the middle-sized side to the middle-sized side. That's the easiest way to do it. Okay? Simplifies to 2/3. Simplifies to 2/3. 10 or 15 simplifies to 2/3. Are the triangles similar? Yes. So I should have done this in the previous one too. We'll say triangle GHJ is similar to triangle, how should I name the other one? GHJ is similar to triangle what? L, G to H to J, so L to M to N. Okay? I should have done that in the previous one too. They did it in the previous one though. They did it right there, so. Okay? By side, similarity. Okay? So I'll hold off on having you do those next two in the your turn. I'll go ahead and let you guys get started on your assignment, okay? So we can just get practice that way. And maybe we'll use that your turn tomorrow for like a warm-up or something, just like I did today. Alrighty. So let me get you guys started on your assignment here. Okay. Let me see what I assigned in the past. Okay, so your homework. We'll start on page 617. I'd like you to do number 1. And then 3 through 15 all and 18. Okay. Now do your assignment. 1, 3 through 15 all. Please make sure you read the directions and answer the questions that are being asked there too. Okay? Please make sure you read those directions and answer the question that's being asked. Okay? I can come around and help here. Two. Yes. Okay.
These two angles, they're not the same.
I see what you're saying. I see what you're
So
saying.
I would say that means that has to be right angle.
So wait, how are you determining that this has to be a right angle? Right. So okay, yeah. So what angle? So you do have the transversal there, but what angles are guaranteed to be congruent based on the transversal? It's not this one. This one. Yeah. There you go. Right.
This would.
So in fact, the triangles, they are well similar, right? Yep. So the ratio here, what is that ratio? What's what equal to what other ratio here? So DE over AB, okay? Oh,
You have to measure it.
never mind. Skip number 1. My apologies. Skip number 1. Forget about it. My apologies. Yeah, don't worry about that. I don't want you to actually have to measure stuff. That's silly. Never mind. My apologies. Skip it. So there you go. Sorry about that.
Wait, what?
Skip number 1. Sorry about that. I don't want you to actually have to worry about measuring things. I mean, I know you can. Really, I'm not going to, have us worry about that.
And if it's not possible, do we just write not possible?
If it's not possible, exactly. Yeah. Or impossible, or yeah.